So today we will be doing some resonance problems, and this will be helping you to understand this concept as we move through these problems. So let's take the 2.20. So for each of the following compounds, locate the lone pair adjacent to C plus, yeah, and draw the resonance structure. So see, in the case A, there is a lone pair on the nitrogen, and because this nitrogen can act here as a nucleophile. Yeah, this nitrogen can act as a nucleophile, and this positively charged carbon atom can behave as a is behaving as a electrophile. So what will happen? We will have a so like that. Yeah, or we can show it here with a new structure. So we'll have one, two, and obviously a double bond will come here. Then nitrogen, and then this and this. Yeah, and because nitrogen is making four bonds, so we have to make sure like we will assign it a positive charge. Yeah, so that's the resonating structure for this one. Now for the B one, now nitrogen is negatively charged, and this there is a positive charge here. So we can see there is a nucleophile, there is an electrophile. So we will a nucleophile donates electron to the electrophile, and we have this, and then we can redraw this as nitrogen, then double bond carbon, and we have one carbon, this, then this, this. We can draw like that. Okay. So, and here no need to put any extra charge on nitrogen because it is having three bonds. Three bond is fine. Three bond is fine. The C part, we can see a positive charge here, and obviously the oxygen is not showing off its lone pair, so we can destroy it. And what can happen is this goes there. So we can just draw it like that in the center. Then we can have a double bond with oxygen to the right of the carbon. Then we can have this. And because oxygen is having three bonds, so we have to assign it a positive charge so that it is not violating the octet rule. Now it is having 8 electrons when we assign the positive charge. Now 2.19, draw the resonance structures for each of the following compounds below. So obviously, like I'm just showing like how to draw this. Like this is the first thing. I just can draw like that. And in the second case, like like this electrophile, this is the nucleophile, so nucleophile have to draw like that. And then in this case, like you can see like there is a electrophile here, there is a nucleophile here as well, there is a nucleophile here as well, and there is alternate single double bond. Yeah, so that the resonance can like first of all, like we have to shift the arrow, move arrow in this direction. Why? Because there is electrophile. Yeah, so electrophile is the one who is seeking electrons, and nucleophile is the one who is giving electrons. So we can do like that. And because as we move this arrow, like we can see like this portion, this carbon now is a electrophilic center now. And because the next we have a pi bond, so again this will act as a nucleophilic center, and then we can have a like this, and then we can draw it like this. So I hope you're understanding what I'm saying. So we will have a bond here, and we will have a bond here, and a positive charge here. So this will be our new resonating structure. We can draw it in steps as well, yes. So I'm just drawing in. So it will have three resonating structures, yes. We have to draw it in steps, yeah. Okay, now this one, we can see like what will happen. Like there is a positive charge here, so one, and then this two, followed by this three. So we have four RS here, yes. We know four RS. Now these are some good things, good facts. Draw resonance structures of the following. So here what we can do is, because oxygen, like carbonyl group, oxygen is more electronegative than carbon, and this bond always takes in this fashion because oxygen is more electronegative. So here we draw like that, and then this double bond here, yeah, because this is this carbon, this carbonyl, this carbon is electrophilic center, yes. And this double bond is acting as a nucleophile. So we can draw the structure like this, O negative. And then we have double bond and then carbon and positive charge. Yeah, so this will be the. For this one, you can just draw like that and that. So it will have 3 RS. And then for this one, because this is a negative charge here in the center, which is the nucleophile, and this you can create an electrophile here by shifting this bond here, and then this will be electrophile. And then obviously I can draw this for it. It will be 1, 2, 3, 4, and the double bond here, and a negative charge here. So this will be the second 2 RS here. And the next figure, like this is a very good thing, like because we know that oxygen has some lone pairs. So and this bond due to polarity it breaks like this. This carbon becomes electrophilic center, this carbon, and which is further entertained by the lone pair of oxygen. So we can draw like that. Here with the yellow I'm drawing, we have O negative, and then a double bond O obviously, and then this. And the oxygen will bear a positive charge because obviously it has 3 bonds. Yeah, it's your wish. Like you can show the lone pairs, don't show, but it's the bond should be like that. The E part, there is a lone pair here, and then there is a electrophile here. There is a nucleophile here. Yes, electrophile here. So what will happen? This will be like that. So we will have O double bond this. And because oxygen is now having 3 bonds, so we have to place a positive charge. In this case, this can go like that, and like that, because alternate single double bonds. And because oxygen is more electronegative, so it will withdraw the electrons. And we have like 1, 2, 3, 4 RS here. Withdrawn. And here the nitrogen has some lone pair, so again this one. And then nitrogen will make a double bond, so it will be at a positive charge. And I leave this to you, yes, whether it will be resonance or not. And yeah, there may be a chance like there is no resonance. Okay. So this is like that, and there is a lone pair here, which will be moving there. So we will have like and then this an O negative, and then we have a double bond here, and nitrogen having 4 bonds, so we have placed a positive charge here. Like this we have a and yeah, double bond OCl, and there is Cl has some lone pairs. So obviously that can go there. So we have O negative, and then, which obviously doesn't look very well. Yes. For each of the following, draw all significant resonance forms and rank them from most significant to the least significant. Briefly explain the rankings. So in the part 1, we have a negative charge here. So we will cover the other part in another video. So till now, like these 3 we are done. Okay, so thank you. And please share your comments like how you like the video and subscribe. Thank you. Nice learning.